This particular problem involves a timber vessel. The vessel's completed the underdeck loading with the displacement and a kg given. And during the passage, 200 tonnes of heavy fuel oil was consumed from number 3 double bottom tank centre, which was full on departure. And calculate the maximum weight of timber to load on deck kg 12.6, assuming 15% water absorption during the passage, in order to arrive at the destination with the minimum GM 0.05, and 0.05 for timber vessels is the what's allowed under the load line regs. With this problem, you always have to assume that the km is constant. So we get the km at the initial displacement of 15,040. Once we've got that, then we know our final km, we know our final GM, we can find our final kg, and then of course we can use the tables to solve the problem, not forgetting that once we've consumed from number 3 double bottom tank, we've got free surface moments. So we go in the tables at 15,040, the km is 8.33, so the final kg is 8.28. Number 3 double bottom centre, kg in the table is 0.6, 0.598 was the original value. Free surface moments of course are fresh water, 1142, so we correct those, multiplying it by the density of the oil, 0.8, so we get 914, and we let x equal the weight of the deck timber. Initial displacement, initial kg, and the moments. So we're given our initial displacement, initial kg. Fuel consumption, we've used 200, 0.6, it won't really make any difference here, it's still the same, 120. Free surface moments added of course, so we've subtracted the fuel moments and added the free surface moments. We'll call the deck timber 1.15x because of course we've got to allow 15% absorption. You could have called it x and then worked out the value to take off at the end, but you may forget to do that, so it's always best to include the 1.15 in the table straight away. So we get 14.49x. Total weight, total moments, divide one by the other, and we know that the final kg is 8.28, so 8.28 equals moments over weight. 8.28 times 14,840 plus 1.15 equals 122,875 plus 9.52x. So we say that that value equals the 121,114 plus 14.49. So that times that equals that, and of course when we do the cross multiplication it equals that value on the top. Subtract that from that, subtract that from that, 1761 equals 4.97x, so x equals 3.54. So the maximum weight of timber, 3.54. If you had time and you wanted to, of course, you could put that weight in here instead of x, work your way through, and of course you should get your final kg of 8.28 if you've done everything correctly. So there is a way you can check your answer on this particular problem to make sure you've got the right value.